Good evening, this is Ashwin.
Hello, this is Vicky.
Hi, this is Pramod.
So now we are going to talk about the project which we have made, that is smart door lock system, which can be accessed using mobile phone. Okay, so the components which we are going to use in this project are solenoid lock, an ESP8266 module, and then a buzzer, a relay, a two-way relay, and a 12-volt power supply. So now talking in detail about the components which we have used. First, solenoid lock. A solenoid lock is a replacement for a conventional locking system which can be operated manually by using our hands. So a solenoid lock is a locking system which uses a solenoid inside the lock, which is enabled using a two-way relay. So a two-way relay enables the lock in the solenoid lock, which opens the latch and closes the latch when needed. And the power supply which is required for the solenoid lock is 12 volt. It can also be operated using 9 volt power supply, but the processor will be slow. So here in our project we are going to use a 12 volt power supply which is given using a external adapter. The next component which we have used, which is the important key aspect of the project, is ESP8266 microcontroller, which is a 32-bit microcontroller which enables which gives access to Wi-Fi. So talking in detail about the ESP8266 chip, the ESP8266 chip operates in three types of mode. The first mode is access point mode. In access point mode, the ESP8266 acts as a Wi-Fi network which can be connected to any kind of external devices, and it acts as a two-way communication between the device which is connected and the module. So which doesn't mean that you can use Facebook or some other app using your mobile phone. It's just a common communication which is established in between the device and the module. So the next type of mode which we are going to discuss is STA mode. In an STA mode, the ESP8266 doesn't operate like a Wi-Fi system. Here in this case, we can connect the module to the already prevailing Wi-Fi network which is available in the area which we are going to fix the smart door lock. So in our project we have used the ESP module in STA mode. The ESP8266 microcontroller typically comes in various development boards, each with its own pinout configuration. So now talking in detail about the pins, we have GPIO, which is general purpose input output pins, which are the versatile and can be configured as either input or output pins, allowing the ESP8266 to interact with external devices such as sensors, LEDs or switches. So the next pin is RX and TX pins. These pins are used for serial communication, typically with other devices or microcontrollers. RX is used to receive data and TX is used to transmit data. Next type of pin is VCC and ground. These pins provide power to the microcontroller. VCC supplies the operating voltage, while ground is the ground reference. So now the ESP module operates in two types of voltage, that is 3.3 and 5 volt. Some boards may have separate pins for providing 3.3 volts and 5 volts of power. The ESP8266 typically operates at 3.3 volts. So next type of pin is I2C, which is integrated circuit pins. That is, I2C pins are used for two wires serial communication with other devices such as sensors and peripherals. The next pin is reset pin. This pin is used to reset the microcontroller. Pulling this pin low momentarily resets the microcontroller, often restarting the program running on it.
So the next component we are going to talk about is a two-way relay module. We might want to use an ESP8266 to control these high voltage appliances like a lamp, fan or other household devices. However, this ESP8266 controls a maximum voltage of 3.6 volts. Using this we cannot control high voltage appliances. So this is where a two-way relay module comes into play. So the relay is an electromagnet which has typically 5 pins, 3 of which are high voltage terminals, NC, NO, COM, that connect to the device being controlled. The device is connected between the common terminal and neither the NC normally closed or NO normally open terminal, depending on whether the device should remain normally on or off. Between the remaining 2 pins, coil 1 and coil 2, is a coil that acts as an electromagnet. Normally the COM terminal is connected to the NC terminal and the NO terminal is open. When current flows through the coil, the electromagnet becomes energized, causing the switch internal contact to move. The COM then connects to the NO terminal, disconnecting from the NC terminal. When the current stops flowing through the coil, the internal contact is returned to its initial position, reconnecting the NC terminal to the COM and reopening to the NO terminal. On the other side of the module, there are two input pins, I1 and I2. for controlling the relay. These pins are 5 volt logic compatible, so if you have a microcontroller, you can drive a relay with any digital output pin. The input pins are active low, which means that a logic low activates the relay and a logic high deactivates it. A VCC pin provides power to the built-in optocouplers, and optionally the relay's electromagnet connected to the 5 volt pin on the ESP8266. Ground is the common ground pin. Ion 1 and Ion 2 pins control the relay. These are active low pins, which means that pulling them low activates the relay and pulling them high deactivates it. COM terminal connects to the device you intend to control. NC terminal is normally connected to the COM terminal unless you activate the relay, which breaks the connection. NO terminal is normally open unless you activate the relay that connects it to the COM terminal. So the next component is a buzzer. Buzzer is an electronic device that produces sound when an electrical signal is applied to it. So in our project, the buzzer gives an audible feedback when the lock is activated or deactivated, alerting the users. And this is all about the components, and these components have been soldered in the perf board.
So talking about the connections are pretty simple since we have used only 4 components. That is the buzzer, NodeMCU ESP8266, the two-way relay and solenoid lock, and finally the jack for providing 12 volt supply to the solenoid lock. And the input pin of the relay is connected to the D4 pin of the ESP8266 for providing trigger signals to control the lock and unlock operations of the smart door lock. And then the buzzer, the power button of the buzzer is connected to the D7 pin of NodeMCU so that it signals whenever the lock is unlocked or locked. And the normally open pin of the relay, which is usually open when it doesn't receive any electrical signal, is connected to the ground of the solenoid lock so that whenever it receives a trigger, the switch is connected and we can perform unlock and lock operations. So usually for locking the door, we have used low trigger, which means the normally open pin operates in a normal state, that is, it is unlocked and then the solenoid lock remains closed. And for the closed status, it's literally the opposite, vice versa. And the power pin of the solenoid lock is connected to the positive terminal of the 12 volt supply, which is used to transmit power to the solenoid lock when the relay is enabled. And now that we are done with the hardware part of the project, I'm going to explain about the code that we have performed for the project. So starting with the inclusion of ESP8266 Wi-Fi mod library and ESP8266 web server library. These libraries are necessary for connecting Wi-Fi and setting up a web server on a ESP device. And then we are setting up the SSID, that is the name of the Wi-Fi network that we are going to operate on, and the password of the Wi-Fi network. And then we are going to setting up the web server by using the syntax ESP8266 web server 80, and this line will create a web server object on port 80, which is the default port for HTTP communication protocol. And then we are setting up we are configuring the relay pin and buzzer pin at D4 and D7 pins respectively. And then we are defining a variable door lock true, which is a boolean variable to lock or unlock the door. And then we are using a void loop function where the ESP8266 module will run on a loop when we have imported the code to it. And then the server on handle on connect function defines different rules for the web server. When a client requests these routes, the corresponding handler functions handle on connect, handle lock, handle unlock, and handle not found are called. Void handle on connect. This function generates the HTML page served at root URL. It displays current status of the door, that is either shows if the lock is locked or unlocked, and provides button to lock and unlock the door. Void handle unlock is a similar function that is used to perform unlocking option of the door, and void handle lock is used to perform the lock option of the door. The void handle not found. This function is used when a root that we have requested that doesn't exist. It sends a not found response with the status code of 404.
Okay, so now we are going to show the live demo of our project. So now this is the code which we are going to execute in the Arduino IDE. So once the execute button is clicked, we get the IP address which can be connected to the mobile phone to the local Wi-Fi network, which we have enabled using the personal hotspot, which we have explained in the coding section. So now once the connection is established in our mobile phone, the web interface. So once the connection is established in the mobile phone, we get this particular web page using which we can access the lock which we have formed. So now this is the components which we have finally soldered on the perf board, and now once the lock button is given, the lock is locked. When the unlock button is given, the lock is unlocked. So now the status is also displayed. So the status is also displayed on the mobile phone, whether the lock is locked or unlocked. So when the lock is locked, we get the status as locked, and then when the unlock button is given, the status is shown as unlocked, which is also shown on the serial monitor. So we get the serial monitor, we get the status of the lock in the serial monitor as well. So this is all about the working demo of our project. Thank you.